Welcome to our module on boilers and steam systems. In this session, we'll cover the fundamentals of industrial steam systems, common issues, and best management practices. We'll also explore tools for conducting steam audits and discuss source reduction strategies to ensure your steam systems remain efficient and sustainable. Steam is widely used for mechanical power production, space heating, and process applications. It is efficient and easy to distribute, making it a versatile energy carrier. Let's first talk about how steam is produced. 1. Raw feed water must be treated to remove minerals, manage pH, and eliminate oxygen to prevent scaling, fouling, and corrosion. Proper pretreatment ensures the steam system operates efficiently. 2. Feed water enters the boiler, and the boiler makes steam. 3. Steam is piped to the application. Pressure regulators may be present depending on the end application. 4. As steam loses heat energy, it condenses back into water. This condensate is collected in steam traps, which then discharge condensate, air, and CO2, keeping steam in the system. If the condensate can be collected, it should be returned to the boiler as feed water. Common issues in steam systems can include poor boiler tube condition. Boiler tubes can start to have mineral or soot buildup, and this causes inefficient heat transfer within the boiler, making energy consumption and costs rise. Excessive blowdown. Blowdown is the removal of sediments left behind as the feed water boils. This process can waste water, chemicals, and energy. Optimizing blowdown will make the system most efficient. Worn-out insulation. Effective insulation can reduce losses by 90%. Insulate any surfaces with a temperature above 120 degrees. Check insulation periodically and replace wet or missing insulation in your annual preventative maintenance plan. Steam leaks. Steam leaks can happen anywhere in the system. These leaks create artificial demand that causes more strain on the system. Conducting a leak audit can help find a lot of these leaks. Trap failures. If traps fail closed, they can let condensate through, which in turn causes water hammer. If traps fail open, steam can get into the condensate system lines, which can damage the system. Both types of failure can be found during a regular steam trap audit. Addressing these issues can significantly improve system efficiency and reduce costs. A critical component to effective steam management is conducting regular steam leak audits. These audits ensure any issues or leaks are identified and repaired quickly before significant losses or problems can occur. To conduct a steam leak audit, plan thoroughly, assemble a knowledgeable team, review P&IDs, and have a data collection plan. Use ultrasonic leak detectors and thermal imagers to identify leaks and assess trap performance. Best practices for steam systems include identifying ways to improve the amount of condensate returned to the deaerator, evaluating the use of economizers to preheat feed water, and exploring methods to use waste heat in other building or process applications to ensure optimal performance. To recap, we've discussed steam system basics, common issues, best management practices, and how to conduct a steam leak audit. Now let's test your knowledge. 1. What are the main issues with poor boiler tube condition? A. Soot. B. Pitting. C. Corrosion. D. All of the above. 2. What is the minimum temperature of a pipe that should be insulated? A. 120 degrees Fahrenheit. B. 75 degrees Fahrenheit. C. 90 degrees Fahrenheit. D. 130 degrees Fahrenheit. Thank you for watching. Stay tuned for more insights and strategies in our upcoming videos.